It's been a pleasure.
Ladies and gentlemen, please welcome Chairman and CEO, Rockwell Automation, Keith Nosbusch.
Well, good afternoon, everyone. It's great to be back at the Internet of Things World Forum. Absolutely delighted to be here in Chicago at the second World Forum and the opportunity to share progress on the industrial Internet of Things with so many business leaders and visionaries. And I'd like to personally thank John Chambers and the Cisco team for their great leadership in organizing the event. And what a great way to accelerate collaboration and sharing to make the Internet of Things a reality. In our view, the industrial Internet of Things is transformational. IoT technologies enhance the connection between the different parts of an enterprise, such as industrial production and supply chain, to realize what we call the connected enterprise. Today, we will discuss such things and trends as IoT-OT convergence and the role of IoT technologies in enabling this convergence. I'll describe several real-world use cases of industrial IoT and discuss the application of IoT technologies and the resulting transformational benefits. Finally, I'll wrap up with a summary of the challenges that we all need to collectively address in order to achieve the potential value and innovation from the IoT. Let me first introduce you to Rockwell Automation. Rockwell Automation is a leading global provider of industrial power control and information solutions. In fact, we are the largest company in the world that is solely focused on industrial automation and information. It is all we do. We serve a very wide range of industries, from automotive and consumer packaged goods to mining and oil and gas. We have a long history of serving our customers. This year, we will be 111 years old. We attribute our success over the years to our intense focus on technology innovation, deep domain expertise in all the industry verticals that we serve, and a culture of integrity and corporate responsibility. Our passion for technology innovation is what brings us to the IoT World Forum today. We're here to learn from all of you, and we're here to share our progress and expertise in the application of IoT technologies to industrial automation. As we heard earlier today, this year's World Forum is focused on how IoT is solving real-world problems and adding tangible value to businesses and people's lives. So from our perspective of the industrial world, what's driving our customers today? At a high level, across all the industries that we serve, we find that following four value drivers are the most important to our customers: faster time to market, lower total cost of ownership, improved asset utilization, and enterprise risk management. The applications of IoT technologies must help our customers realize tangible business value in one or more of these four values. To help our customers in their pursuit of the four value drivers, we have created a vision called the Connected Enterprise. The Connected Enterprise is focused on rapid value creation through the tighter integration between the industrial assets and the rest of the enterprise value chain, from suppliers to customers, from machine builders to industrial end users, from the plant floor to across the enterprise. The results is an enterprise that can be optimized to drive quantified value. We believe that we are at the inflection point for the realization of the connected enterprise for our customers. enabled by integrated control and information, enhanced by the Internet of Things technologies, and we'll talk about both of those later. We are just beginning the journey to the connected enterprise. The journey is driven by the convergence of IT and OT. Central to achieving the connected enterprise is the need to converge information technology, IT, and operations technology, OT. OT is the world of industrial equipment, machines, controllers, sensors, actuators. IT is the world of end-to-end business processes, ERP, CRM systems, supply chain management, logistics, and HR. Historically, these are two different worlds with different cultures, priorities, and base technologies. Critical to the OT side is real-time data, which drives safety, security, and control. Real-time data is typically connected and acted upon in milliseconds or microseconds. Frankly, reliable and repeatable process for control and security are paramount on the plant floor. Many plants need to run 24/7, safely and securely. Industrial processes cannot tolerate shutdowns for software updates. On the IT side, transactional data and business systems form the backbone, with their own priorities on what is mission critical. Transactions may take several seconds or even minutes, and the IT side is more tolerant of software patches and updates that may sometimes shut down a computer or two. Both IT and OT are critical to the success of an industrial enterprise, but true convergence between these two worlds remains a challenge. Through our strategic alliance with Cisco, we both provide market leadership to drive IT and OT convergence. Over the past several years, we have been working together to bridge this gap. We've made tremendous progress in our joint efforts to bring a robust IP-based network infrastructure to industrial automation with a broad range of jointly developed hardware and software products, solutions, and services. This flatter, more open approach to industrial networking has delivered a level of performance and flexibility that was simply not achievable with the previous generations of proprietary industrial technology, and is the foundation for driving IT and OT convergence. But we've only scratched the surface, as only a few of the most progressive manufacturers have truly managed to bridge the IT-OT divide today. Today, the industrial enterprise has many smart things. We've defined a smart thing as simply an asset with a microprocessor and a network connection. In fact, there are often thousands of such intelligent assets in a typical manufacturing site. Machines and processing equipment in most plants have long been automated with high-performance control systems that ensure safe, reliable operation. These assets are rich in data that could be used for optimizing production yield and asset uptime, reduce bottlenecks and improve responsiveness to changes in demand. Yet today, only a small percentage of plant-level assets are connected to the enterprise network. According to Industry Week, less than 14% of manufacturers have connected their machines to the enterprise network. Clearly, we have a huge opportunity here. With IoT technologies, we can enable the connection and help bridge the IT-OT divide. As more manufacturers bridge the IT-OT divide, they will be able to transform all the big data on the plant floor to help make faster decisions and rapidly drive value. Let's discuss how the large amount of data in industrial plants can be transformed into actionable information and new value. Consider a simple example of data from a typical smart asset in manufacturing. Here, we see a pump that is powered by an electrical motor and controlled by a variable speed drive, a very commonplace intelligent industrial thing. The variable speed drive has the ability to not only control the speed and torque of the motor, but also to sense the current and voltage. This data is available several thousand times per second within the drive. Through contextualization of this data, we can deliver and infer the load on the motor or pump and associate that data with process conditions. In this example, it is simply relating that data to the pump's operating condition. We call contextualized data information, and it lets us diagnose situations such as motor overload. The next level of refinement of this information is to convert it to knowledge through analytics. Knowledge such as prediction of failures. When this knowledge is shared with the plant maintenance worker, they can take actions to maintain that asset before it fails. This knowledge can be further refined into wisdom. Over time, aggregation of knowledge from hundreds of pumps displayed around the globe will lead to deeper insights that may result in design improvements and optimization of next-generation designs. We call this step wisdom. This is truly an exciting data transformation proposition that leverages IT-OT convergence. Industrial IoT is not a single technology. It is a collection of 5 technologies that give us scale and flexibility in the industrial world. These 5 technologies are enabling IT-OT convergence today to help us realize the connected enterprise. The foundation is an ever smarter industrial asset coupled to a modern multidiscipline control and information portfolio through secure IP-based network infrastructure. Smart assets communicate over the secure IP network infrastructure using an open standard industrial protocol called the Common Industrial Protocol, or CIP. Today, CIP is being enhanced to become the common language of industrial IoT. The data from these smart assets will be processed and aggregated in hierarchical, scalable computing layers. Scalable computing layers starts on the plant floor with multidiscipline control and information, edge computing, and plant floor servers. Analytics may take place here locally or in the cloud. We see this layered computing model as an important element of industrial IoT. Further, contemporary mobility platforms bring information, visibility, collaboration, and remote expertise into the hands of those who need it the most, the front lines of operations. Individually, each of these IoT technologies can add value to industrial processes, but when integrated together, we can build powerful solutions that deliver transformational business value. By making the convergence of IT and OT the most cost-effective and scalable, industrial IoT technologies enhance the connected enterprise in ways never before possible, leading to even greater productivity and global competitiveness. We see this as transformational. In fact, we believe industrial operations will change more radically in the next 10 years than in the last 50. Cisco's own research confirms this perspective. Their survey of the IoT landscape estimated that 34% of the entire IoT opportunity would be found in the manufacturing segment. The share in manufacturing is very significant, a huge number, no doubt, but one that reflects the great need of industry to unleash untapped value within all of these industrial things. We are helping our customers apply industrial IoT technologies to realize the connected enterprise through innovation of processes and business models that result in tangible business value in the 4 areas that are highlighted here. Let me share with you a few of those real-world examples of IoT in action. While all industrial IoT applications start with smart assets, it is helpful to think of two types of applications. These applications are different in sophistication of computing and communications. The first is smart assets that are distributed in the field and often in remote locations. An example of such smart assets would be oil wells. For such assets, services such as predictive maintenance are now practical through the application of industrial IoT technologies. Remote expert models allow the positioning and provisioning of these services in a much more cost-effective and timely manner, versus a model which once required an expert to get on a plane and travel halfway around the world. In many heavy industries, this is particularly an attractive model, as equipment is often based in inhospitable locations. The second set of use cases for an industrial IoT is in-plant applications. Smart assets are typically in plants, and they have greater computing and communications with connectivity than distributed assets. Manufacturers are using industrial IoT technologies for connecting data from multiple machines and lines with enterprise systems to realize the connected enterprise. This connectivity enhances the ability to compare and optimize operational performance across multiple machines, lines, plant sites, and across entire supply chains. We note that the distinction between smart assets in the field and plant-wide smart assets is not black and white. There are some smart assets in the field, such as subsea platforms, that are as sophisticated as a plant. And there are some simple plants that do not have significant computing and network connectivity. Assets such as oil pump jacks, pipelines, tank farms, offshore platforms, and mine-based conveyors make up the backbones of natural resource industries such as oil and gas and mining. These assets need to be placed where the natural resources are, often remote and sometimes inhospitable locations. While it was once very expensive and problematic to connect remotely with these sites, today, through IoT technologies like cellular and satellite communications and cloud-based computing, it is much more practical and cost-effective to enable the management of these assets. There is much talk these days about big data analytics, automatically extracting insights from the complex patterns in terabytes of data. Yet our experience in the industrial world is that most remote asset applications include some form of man-in-the-loop, an expert who can blend timely information access with years of experience to create real-world insights and decisions for what actions to take. In fact, the killer app that IoT enables is that of asset performance management. A good example of field-based remote asset management is that of monitoring leased automatic custody transfer, or LACT units. These LACT units are found at every junction between production facilities, trucks, rail cars, pipelines, and storage tanks for both onshore and offshore oil and gas operations. The main objective as LACT is to accurately measure, sample, and transfer hydrocarbons between the buyer and the seller. Today, the industry is challenged by measurement error, human error, and billing delays. We have developed solutions with IoT technologies for several companies who are deploying and monitoring LACT transfer stations and have provided an information-enabled automation architecture and a cloud-based asset management solution for real-time measurement and billing information. This information is now available securely from virtually anywhere on any smart device or tablet. This is improving their ability to monitor and support their equipment. These companies are implementing a new business model, a model to improve profitability. They have reduced billing cycles from 30 to 90 days to 7 to 10 days due to the automated real-time measurements and remote monitoring. This innovative solution is providing significant and transformational value to all participants in the supply chain. Another example of remote asset management is the monitoring of liquefied natural gas, LNG, refueling stations. As many of you know, the forecast for worldwide demand for LNG is expected to increase by about 60% over the next 30 years. As LNG use grows, we need a better solution for managing and monitoring the refueling stations. Chart Industries, a partner of Rockwell Automation, is providing LNG refueling stations for Shell Global. Shell's vision is to provide stations strategically in North America to refuel semi-trucks for shipping LNG across the United States. They need to track sales transactions, trends, alarms, diagnostics, and the overall status of each LNG station, since many of these stations are unmanned. Rockwell Automation is working with Chart Industries and Shell Global to provide remote monitoring services and solutions for the LNG refueling stations. With a focus on security, data integrity, and time to market, we are deploying cloud-based solutions to provide real-time visibility to asset utilization and site performance. Also, secure, role-based reporting is provided users with flexible, customizable reports, converting and including current and historical data that will support not only day-to-day operations, but improve asset performance and business performance across all the stations as they're deployed over time. Chart and Shell clearly see the value of an innovative cloud-based asset management solution to allow them to scale from 1 to thousands of stations with minimal infrastructure and maintain flexibility for future growth. Today, energy markets are expanding, and energy companies are very sensitive to the environment and the costs associated with remote exploration and reservoir development. We are deploying more smart assets to highly distributed remote locations and optimizing these assets to deliver the performance at an individual well and at the oil field level. The digital oil field is a concept that is getting more traction as a result of IoT technologies. The objective of the digital oil field is to speed up and streamline all production decision processes. In an oil field, there are many decisions that are taken every day, impacting production rates, cost containment, and safety. The oil industry has been making these decisions based on data gathered in the field using predefined workflows. The digital oil field enables the automation of these workflows to accelerate that decision-making process and achieve faster time to benefit of the assets. As pump jacks are deployed across an oil field, intelligent controls and sensors through Rockwell Automation's vMonitor SCADA system report back to a central system using IP-based communications and the cloud. The diagnostics and performance characteristics for each pump are then determined in the cloud. Multi-well performance characterization and optimization result in significant improvements in uptime and efficiency. We have discussed 3 examples of field-based smart assets where the application of IoT technologies that enhance the connected enterprise resulted in significant tangible customer benefits. As I mentioned before, we believe remote monitoring and performance optimization of such assets is a killer app for industrial IoT. Let's turn now to the industrial IoT application found in plants. Plants typically have a large collection of smart assets, such as machines, lines, process equipment, and controllers. Smart assets in a plant generate significant amounts of data. Since plants have computing assets such as controllers, network equipment, and perhaps servers, localized processing can yield information and sometimes knowledge. Decisions from localized processing can be more immediate and impact the operation of the plant in real time. Remote processing of information in a cloud of remote servers is typical and used to run analytics, and the resulting decisions are implemented in non-real time. Analytics can produce prognostics, multi-plant comparisons, and process optimization that can significantly improve productivity and global competitiveness of the plant. A plant-wide application that illustrates the connectivity between smart assets and multidisciplinary control platforms and to the cloud, yielding significant new business value, will be talked about next. At one of the world's largest food companies, we are making and working together to make the connected enterprise a reality through scalable, modular control and information that is enhanced by IoT technologies. Machines from multiple manufacturers are being equipped with a standardized set of functionality that allows commonized reporting of machine configuration information and key production parameters such as operational equipment effectiveness, or OEE. All machines communicate in real time over the open IP-based network, unmodified standard Ethernet, using the Common Industrial Protocol. Information about each machine and line is aggregated through pre-configured industrial data centers in each plant. This information, along with configuration health and security of the plant's IT infrastructure, is shared via the cloud to allow visibility and production optimization across multiple plants. When complete, a network of well over 100 plants around the globe will form the core of this manufacturer's connected enterprise. Another example of how IoT technologies are enhancing the value of the connected enterprise is product serialization. The media has made us aware of the global issues around counterfeiting across several industries, such as the pharmaceutical industry, baby food, and other high-value consumer product goods. Counterfeiting is on the rise and is a growing health and safety issue, with deep financial and non-financial consequences for business, governments, and the consumer. Rockwell Automation has teamed with Covectra to provide a multi-level serialization solution with a cloud-based serial number generation management and event repository. This serialization solution is based on our integrated control and information that provides flexibility and inherent capabilities to interface with enterprise systems as well as machine and line controllers. We enable track and trace to improve quality and customer confidence, meet regulatory standards, and ensure authenticity through the complete holistic solution that allows for serialization and aggregation of the cans, boxes, cases, and pallets embedded in the packaging lines without impacting the effectiveness of the lines. With this solution, product serial numbers can be authenticated quickly anywhere along the supply chain. This product serialization helps companies protect their brand by making counterfeiting very difficult. We will be talking more about this example during our panel later today on manufacturing IoT use cases, opportunities, and challenges. Let me now share how Rockwell Automation is realizing the connected enterprise. We have been on a multi-year journey to connect our global manufacturing footprint to the rest of our enterprise. Like many industrial and manufacturing companies, Rockwell Automation has a diverse product portfolio. We have plants spread across the globe and across a variety of manufacturing processes. with up to 200 different stock keeping units or SKUs, and a product life that can exceed 20 years. That's the mine, that's 200 years, I guess. In addition to the standard or make-to-stock manufacturing, some sites are geared toward engineered-to-order manufacturing. These sites produce custom-made products and parts. Others are configured-to-order manufacturing plants that configure all variable parameters associated with a base product when chosen by a customer. We decided to transform our manufacturing and supply chain to support our growth and performance strategy and to meet lead time requirements for our customers around the globe. This transformation to the connected enterprise centered on people, technology, and processes. Prior to realizing the connected enterprise, each plant was running a different ERP system and had its own custom applications that captured and analyzed data in different ways. We had no visibility to critical information such as inventory and quality within these legacy plants. With this environment, we made the difficult decision to run with one global ERP system and standardize on common software across all the plants. We focused on building a standardized system and process to check and measure performance of all plants with common metrics, gain the right data at the right time from anywhere to make faster, smarter decisions to help control quality and improve productivity. To converge IT and OT, we had to drive both cultural and technological changes while implementing new technology, standardized processes, and retrained people. The implementation utilized our integrated control and information software and hardware products portfolio, including FactoryTalk Production Center for MES, FactoryTalk Vantage Point for plant-wide metrics and dashboards, and the Logix platform for multidiscipline control. A secure network infrastructure was implemented in partnership with Cisco. All smart assets communicate using the Common Industrial Protocol, the language of industrial IoT. Through this implementation, we have complete visibility into our production facilities. Also, operator certifications and quality levels are automatically checked and updated at each plant. Through a significant savings in technology with changes in processes and people, we successfully aligned our manufacturing and supply chain to serve our customers where they are. So what were the benefits? Was it worth it? Did it matter? Did it make a difference? Our journey has brought forth significant improvements. Lowered inventory from 120 days to 82 days. Captured 30% savings annually in capital avoidance. Improved supply chain delivery from mid-80s to 96%. Reduced lead times by 50%. Improved customer service metrics, including time to want, from 82% to 98%. And reduced parts per million quality issues by 50%. This is equal to improving productivity an estimated 4 to 5% per year. Of course, this is an ongoing journey. We see the IoT technologies helping us improve and optimize our plant and supply networks globally. While the application of IoT holds great promise, it is a set of technologies with its own share of challenges. Some of the most significant challenges are shown here. Information security, data privacy, interoperability and standards, data semantics, analytics. Even if we could completely address all of these technical challenges, in the industrial world, we still face a significant competency gap when it comes to adopting new technologies such as IoT. For industry to progress, we must address these challenges together. One of the primary reasons for being here at the World Forum is to share our experiences with you and to align our efforts with others. In fact, partnering for the good of our customers is one of our longest-standing best practices. It is a core part of our DNA as a company. In addition to our strategic alliance with Cisco, we have partnered with other IT and OT leaders to continue to drive forward the connected enterprise. Here we are collaborating with market leaders to solve real-world customer problems, which we couldn't solve on our own. Throughout this World Forum, you will be hearing from key strategic partners and industrial market leaders such as Endress & Hauser, Fanuc, and Panduit. They too will be sharing their experience and learnings from deploying IoT technologies for our mutual customers around the world. We, along with these companies, are working with key standards bodies, academia, and working on initiatives like the Industrial IP Advantage to help ensure that emerging IoT technology can be leveraged by all. Of the many challenges facing the broad adoption of IoT technologies in industries, perhaps none is more important to address than the broad range of competency challenges. To address these challenges, we and our partners are making major investments in time, talent, and resources to address the competency needs of industry. Our science, technology, engineering, and math STEM agenda includes a long-standing partnership with FIRST and the FIRST Robotics Competition, giving middle and high school students an exciting exposure to technology in a playful, competitive, collaborative environment. We have made investments in leading universities around the world to create a network of nearly 100 teaching laboratories equipped with contemporary control and information equipment and software. Along with Cisco, we are developing extensions of the core network certification for the industrial user. We also supplement our custom in-house competencies with co-developed managed services to help them with their IT-OT convergence. Today, we are announcing our participation in the Industry Talent Consortium, another great opportunity to help lead the manufacturing industry into the future. And finally, tomorrow night, during the World Forum Hospitality event at the Science and Industry Museum, be sure to stop by the Rockwell Automation-sponsored Toymaker 3000 exhibit, where we help students in the Chicago area get a glimpse of advanced manufacturing in action. In closing, I'd like to again thank Cisco and John Chambers for allowing us to participate and share our exciting progress in industrial IoT at this premier event. It's been my pleasure to share with you our vision of the connected enterprise and some of the real-world applications of IoT technologies. These are exciting times, the first time in my career where we have seen the convergence of interests across so many different market segments to a common set of technologies. IoT clearly is a game changer in the industrial world and beyond. I and my leadership team look forward to discussing this exciting future with all of you over the next 3 days. Thank you very much for your time and attention today.